Hello, welcome to the mathematics lesson. So today's mathematics lesson will be on factorization. Okay, so under factorization, we will look at normal factorization, and also we'll look at normal factorization. We'll also look at factorization of quadratic functions. So we'll look at factorization of quadratic functions or quadratic expressions rather. Okay, so that's what we will look at. So now, to begin with, you have to understand what factorization is. So as always, I have to explain. So to factorize is to set aside or separate what is common between terms and also introducing brackets and introducing brackets. So that's what is involved in factorization. So wherever you are doing a factorization, you are just trying to separate or set aside what is known as what is common between terms. Okay, so you set aside what is common and then you introduce the brackets. So there's the introduction of brackets in the process. So in other words, factorization is the opposite of expansion. So we can say factorization is the opposite of expansion. That's what you should know. So whenever you are factorizing, you are doing the opposite of expansion. So these two are the concepts that underlie or that are at the bottom of understanding what factorization is. So enough of the bubble, let's straight go into the work. All right. So to understand the factorization, we have questions with me here. Example, it says factorize the following. So we have this expression which we need to factorize. Okay, we have 4x squared, then we are saying minus 12x. So remember, to factorize, it is to set aside or apart what is common between terms. So we have two terms here, this first term and this second term. So we need to factorize, meaning we need to look at these two terms and identify what is common. So I can see x is common here and also x is common there. Other than that, I can also know that, or I can see that 4 can go in itself and also 4 can go in 12. So 4 also is common. Now that I have identified what is common, it is to set apart what is common. So we will set apart 4 is common and also x. Once we do that, I said we introduce the brackets. So we have the brackets. Then once we introduce the brackets, where we had taken 4, nothing remains in terms of a number. And where we had taken x here, 1x had come out and we remained with 1x, because the x here, there are 2 power 2, meaning there are 2 of them which we are multiplying, but 1 has been taken out, remaining with the 1 here. So 4 is already there. So then you write this minus, like minus, then on 12 here, you realize that once you factor out 4 out of 12, what remains there is 3. So you write 3 like that. Then x is already factored out, then you close. Okay, so this is actually the final answer. Now, remember I told you to say factorization is the opposite of expansion. So if you want to prove whether your factorization was correct, just try to do what? Just try to expand your factorization. So if you have 4x open brackets x minus 3, if it is correct, try to expand it. If it gets back to the original answer, then you are correct. So to expand, we can multiply 4 times 4x times x, which will be 4x times x. Then we'll put the minus there. Then we'll say 4x times 3. So say 4x times 3. So what are we getting? So if we say 4x times x, it will give us 4x squared. Then we'll get our minus there. Then 4x times 3 will get 12x. So this is similar to what we started with. Therefore, our answer, which we did here, is correct. So this is correct. Then we move on to the next question, which is B, 3ax plus 6ab plus 4x plus 8b. So we need to factorize this. So when you look at this, we have got actually like 4 terms here. We have 4 terms. So this one, we can factorize it by grouping. So we need to factorize by grouping. Okay, so here we will group like terms together and look at what is common and factor it out. So what we do, we'll say, okay, this will copy the same question, 3x, oh sorry, that is 3, let me write properly, 3ax plus, then we have 6ab plus, then we have 4x plus 8b. So what we are going to do is to ensure that we look at what is common between 2 terms at least. We have a here and we have a there. Okay, so meaning these are common, we can group them, like we'll factor them out like this. And here at least we have a 4 which can also go into 8. So at least these we can group them and then factor them out. Then we'll say, okay, let's now factor them out. We can see that 3 is also common because it can also go into 6. So a, then 3 is also common. So we'll say 3 and a, they are common. Then we will introduce the brackets. So once 3 and a are done here, we remain with the x, then plus that plus there, you can see we dropped it just there. Then in 6, once 3 has been factored out, you are going to remain with the 2 there, because 3 times 2 should give you back the 6. Then a is already factored out. What we are remaining with is b there. So we'll write our b. Then we'll close the brackets. Then we'll write this plus here, plus. Then 4 is common because it can also go in 8. So we'll factor it out as 4. Then open bracket. You remain with x there because 4 is out. So you say x plus. Then 4 into 8 goes there 2 times. Then there we have a b there. So we'll close. So once we have done that, you realize that we have two terms. We have this term up to there and this term up to there. All right, so these two terms that we see have got something which is common. We have in brackets here, what is inside the bracket is common also here. So you factor that one out. So you say, okay, what is common is x plus 2b. You put it in brackets there. Then once on this side you have removed this, you remain with 3a. So you open brackets 3a. Then on this side, once this has been removed, you remain with plus 4. So you write plus 4. Okay, so this one will be the final answer. So this kind of factorization which undergoes two stages, like you factorized from here, we did one factorization and then we did another one to here. This is what is referred to as completely, factorizing completely. So this one is a complete factorization. So there will be questions which can ask you to say factorize completely. It means a question involves two-stage factorization. All right? So let's move to the next question. The next question is this one, see, which says x squared plus 5x plus 6. So when we have an algebraic expression, if we have an algebraic expression, this one is an algebraic expression. So this is an algebraic expression, okay, in which one variable is raised to the power of 2. Okay, so we are saying in which one variable is raised to the power of 2, then it is a quadratic expression. Okay, then we are going to say it is a quadratic expression. So this one is a quadratic expression because we have a variable which is a letter. We have two variables here. This term has a variable. This term has also have the variable, the same variable, but this variable is raised to the power of 2. Because this variable is raised to the power of 2, therefore this whole expression here is known as a quadratic expression. So now, quadratic expression have a different way of factorizing them. They've got a different way of factorizing them. So what is there? Which way is there to factorize this quadratic expression? So the way which is there to factorize this quadratic expression is what? Is where we need to find what is known as the sum and product. Here we need to find the sum and product first. Sum is the coefficient of this x, which is raised to the power of 1. So in this question, sum is 5. Product is what you get when you get the coefficient. This x has a coefficient. Oh, sorry, a coefficient is a number in front of a letter. Like I said here, the coefficient of x here is this 5 here, a number which is in front. Then the product is found by getting the coefficient of this x to power 1. So the coefficient of this x to power 1, you multiply by this constant here. Like this product can be found if we say the coefficient of this x here, there's 1 here, so it will be 1 times, then the constant here, this number which has got a no letter is known as a constant, so 6, which is equal to 6 actually. So which means that we have the sum is 5, then the product is 6. So once we do this, we need to look for two numbers. We need to look for two numbers. Two numbers, when we add them, they give us 5. Which two numbers, when we add them, they give us 5. The same two numbers should be, when we multiply them, they should give us 6. So here is where creativity is involved. So the two numbers are just 2 and 3. Why? Because if I say 2 plus 3, I'm getting 5, you see? So which is here. Or if I say 2 times 3, sorry, here on this part of my computer, it doesn't write properly. I don't know why it doesn't write properly. Let me try here. So 2 times 3, you see that it gives us 6. So these two numbers are the one. So the first thing we did was to find the sum, which is the coefficient of this. Then the second one is to find the product, which is the value that we get after multiplying the coefficient of x squared and the constant, which we got 1 times 6, we got 6 there. Then after we do that, we look for two numbers, which when we add them, they will give us 5. When we multiply them, they will give us 6. And we found that these are the 2 and 3. 2 plus 3 will give us 5, and then 2 times 3 will give us 6. So once we find those numbers, then we substitute them. We substitute them where? On here. You substitute this part here. So this part will no longer be there. So you say, now you say x to power 2, then now you pick 2, you say plus 2, this 2, you give it x, then you say again plus, you get this 3, you give it x as well, then you come back to plus 6. You've seen? So now, I used to get confused why the teacher, when he taught me that this one should be replaced, I used to say why. In my heart, I never asked. So in case you are also saying why, because this here is the same as this. Okay, if I tell you to say 2, if I tell you to say 2x plus 3x, what am I supposed to get? Because these are like terms, so I add, so I'll get 5x. So meaning, by us replacing 5x by 2x plus 3, which we got after understanding what I've explained here, doesn't affect anything. So once we do that now we can factorize by grouping, because the whole idea is to come up with how many terms? 4. So now we have 4 terms which we can factorize by grouping. So on this side, like this one, we have what is common, x. So say, okay, here x is common, we'll set it aside. Then here 1x is factored out, we remain with x. Then we'll say plus. Here we'll see that the x already came out, so we'll remain with a 2. So we'll say 2, close brackets, then we'll say plus. then here you realize that only 3 is common. It can go in itself and also in 6. So say 3, then say open brackets here will remain with x plus 3 can go into 6 two times. Then we can close. Then we can say okay equals. Then again, once we factorize, we see that this one and this one, they're common. So you factor them again out. So say x plus 2, they're common. Then open brackets here, you remain with x. Then here you remain plus 3. Then you write as your final answer like that. All right. So you also move to another one. So another one was actually this one here. This one. So this one again, it has this x to power 3 and there are 3 terms here. So we'll find the sum. Sum is actually the coefficient of x. X is here, its coefficient here is 1 and there's a negative here, so it will be negative 1. Then product will be the coefficient here and this one here. So it will be 3 times negative 10, which is giving us negative 30. So now we have seen that, all right, the product is 30 and the sum is negative 1. So the product is negative 30 and the sum is negative what? The sum is negative 1 and the product is negative 30. So we need to look at two numbers. Which two numbers, when we multiply them, they will give us 30. When we add them, they'll give us negative 1. Again, you just have to be clever here. There's no clue. So the numbers are actually 5 and 6. So now, one of these numbers, because when you look at the sum is negative, meaning the bigger number is negative. So this is negative. So that if we say 5 plus 6, negative 6, it is going to give us 5 minus 6, which will give us negative 1. Because here I've said positive, negative, negative. Then 5 minus 6, it is negative 1. In line with that. So it means that our choosing of 5 and 6 are correct because we have gotten that. And here, if we also say that 5 times negative 6, we can get what? We can get negative 30. So meaning our choice was correct because it is actually giving us this and that. So these are the two numbers which will give us, when we add them, or give us negative 1. When we multiply them, they'll give us negative 30. Once you do that, substitute. Then you just come say, okay, this means 3x to power 2. Then you come to, you get 5. You say positive 5. You give it x. Then you say negative 6. You give it again x. Then you say minus 10. So here, you look at two numbers, so you factor out like that. If you want, you can rearrange this, but if not, you can't. So let us just rearrange them, but if we don't, the answer is the same. So let's rearrange them. We can get 3x squared goes with negative 6x, then plus 5x goes with a negative 10. I've just done that so that the process goes well. Otherwise, there's no problem there. So you can put this as what we are going to factor them out. So here we see that what is common is 3 and x. So factor out 3x. So here once 3 is out, you remain with x minus, so x3 in 6 can go 2 times there. So you say 2, then the x was already out, so you close the bracket. Then you say plus, then 5 can go in itself and 10, so you have 5 there. Then open brackets here, you remain with x, then minus, then you know that 5 can go into 10 2 times, so you write 2 like that. Then you say, okay, this implies that we have this which is common and that is common, so you write it once, so say x minus 2, then you say open brackets, then 3x plus 5. Okay, so this one will be the final answer. Then we go to the next one, which says 4x squared plus 5 minus 9. This one is a quadratic function. However, despite it being a quadratic function, it doesn't have 3 terms. So we cannot find the sum and the product. So, however, this one is similar to what we call the difference of 2 square. I will explain. This is similar to what we call the factorizing the difference of 2 squares. Factorizing the difference of 2 squares. So now, how? What does factorization of 2 squares mean? Difference. Difference means minus. Okay? Then 2 squares, it means you have 2 squares that are subtracting each other. Like if I have a number like a squared minus b squared, this one can also be factorized because we have this term is a square because it has power 2. That's why it is called a square. And also this term has a square, that one power 2. And there's a minus in between. So that minus is what they call difference. So we have a squared minus b squared, and therefore it qualifies to be a difference of 2 square. Now it has a rule. When it is like this, it can also be factorized, because you might be wondering to say, how can I factorize this when there's nothing which is common? It has a rule. This one is factored out like this. You say a plus b, that is the first, then you close bracket, then you open, you say a minus b. That's how we factorize it. So even this question here, it is a difference of 2 squares which has been hidden. It has been hidden. So let me show you how we can uncover the hidden part. So the hidden part is that this 4 can be written as 2 to power 2. Then we have x power 2, then minus this 9 can be written as 3 to power 2. So you have seen the hidden part that I told you. So the hidden part that I told you is this. Now, this one now, if we say, okay, so this one, let me factorize it now. So this one will come out, you pick this, since both are squared here, 2 squared and x squared minus 3 squared. So since this term we have square square, if you don't want to get confused, you can write like 2x then you do like this, to power 2, meaning they're a square, then minus 3 to power 2. So what I've done is to factor out the square. So the square is away there out, meaning this 2 shares with that power and this x. So you see that this one now stands as one term, just like here, one term, one term. So 2x has one term. So say, okay, this one can come out as 2x plus 3, you do like that. Then also you open brackets, you do like 2x minus 3. Then you close the bracket. So that way you would have factorized this one. Okay, so this is one way. Another way you can factor it out is this way. You have the same 4x to power 2 minus 9, right? So now you don't know what is common here. So we'll do the same, 2 to power 2, x to power 2 minus 3 to power 2. So now if you say let a squared be equal to 2x squared and this one squared, and b equal to 3 to power 2. So like that. So meaning here now you say, okay, here it will be a squared minus this one, you give it b squared. Then according to the factorization, this one will come out as a plus b, then a minus b, like that. Then you substitute now, final. You know where there's a, you put this 2x plus, where there's b, you just put 3. Open brackets, again where there's a without a square, so even this one without a square, 2x, then minus, then b without a square, you put 3 without a square, like that. So that is going to be the answer, just like that, just like the first one. Okay, so this is how you deal with the difference of two squares. Okay, so we go to the next example. The next example is algebraic expression simplifying. So we are going to look at simplification of what we call algebraic functions. Okay, so now functions, not functions, rather fractions. We are talking of fractions. Sorry. So fractions like this. So now here again, if we say simplification and the question says simplify, you must understand that to simplify is to make simple. You know, it's important that whenever you are solving a question, you understand the question, because if you don't understand the question, you may end up failing to answer the question correctly. So when they say simplify, here is how you do. Like we have this question which says x to power 2 over, we have 4x plus x y. So simplification will just require you to factorize what you see to be common where needed and also simplify. For instance, we will say this simply means what is on top there, it means x times x. You simplify, you show what it means. Then over, down here you factor what is common, x, because there's addition. So say x is common out, you remain on this side with 4, then plus, then on the other side you remain with y, you close. Then you realize that at the bottom you have two terms. You have this term multiplying what is inside the brackets. Then on the numerator you have this term again multiplying this term. So it means that if you have two terms on the numerator and the denominator multiplying each other, you can divide them or cancel them, like x into x can go, so that you remain with just one x there, like x, then down here you remain with 4 plus y. That will be the final answer. But don't make a mistake. This is not similar to if I say x plus x, then I say over the same one which is down 4 plus y. Then you say x. Then you say the answer is actually, in fact the answer is remaining almost the same, like x over 4 plus y. But that is not what it means. This one is wrong. If there's no multiplication, you cannot cancel like that. Okay? You can't cancel like that. I hope that makes sense. Unless if there is multiplication, that's why you can cancel like that. Okay? So our final answer is this one. Then we move on to the next question, which is like x plus 1 divided by or over x squared plus 3x. So the same, you say, okay, this one is x plus 1 over x squared plus 3x plus 2. Now, when you look at this one down here, it's a quadratic function. It needs simplification on its own. So x to power 2 plus 3x plus 2 is a quadratic expression which you need to factorize to make it simple. So you look for sum, which is in this case the coefficient of this x, which is 3, product 1 here times this 2, which is 2, so product is 2. So you look for two numbers which when you add them you get 3. When you multiply them you get 2. So these are 1 and oh, let me just put them this side, not there. So these are 1 and 2, because if I say 1 plus 2, I'll get 3, like here. Again, if I say 1 times 2, I'll get these 2 here. So meaning that these are correct. So I'll replace them here. I'll say x squared. Then here I'll replace 1 and 2. I'll say plus 1 just means x plus, then I'll get these 2. I'll give it x, then plus these 2 here. Okay? So you see, that's how it will start going. So now, it will mean now in this next step, we'll say x plus 1 over, we'll get x squared plus x plus 2x plus 2. Then we'll say, okay, now we'll say x plus 1. Here we'll factorize like this. You see now? So here we'll have common here is x. Will remain with 1x there. Plus this side, when x is gone, will remain with 1. Then here plus, what is common here is 2. Open brackets here, x will remain. Plus here, you remain with a 1 because 2 would have gone away. Okay, so let me clear this part so that we can make use of it. So now, we'll say this implies that we can factor out what is common. You see this one and this one are common. So say x plus 1 over. So here we'll have x plus 1. Then open brackets will remain with this x plus 2 close. So you see that this one now and this one, they are similar. So this one is an entire term. This one and this one can go. So once that one is out, on top there is only 1. Then down here you just remain with x plus 2 like that. All right? So that would be the answer there. Okay. Then we come to this one which says express as a single fraction and simplify where possible. So when they say express as a single fraction, it means that they have seen maybe you have multiple fractions. You have either 2 or 3 fractions in whatever you have been given. Like in this question that we have been given, we have 2 fractions here. This one is 2. So we have 2 fractions. So they want us to make these 2 fractions as what? As a single. Meaning we just remain with 1. So here is what you do. So you do the addition, the normal addition of fractions. So you look at common denominators like this. You look for denominator 3 and 2. You look for a number in which the 2 can go without a remainder, which is actually 6. You write 6 there. Then you say 3 into 6, how many times? 2. 2 times this term on top. So say 3 into 6, 2. 2 times that on top. You just write 2 times x plus 1. You see, when I say times, I put in brackets. Okay, that. It means that term, it is times 2. Okay. Then, what I will do again, I'll say, I'll put this plus here. Okay. So that plus has gone there. Then I'll say again 2 into 6, 3. 3 times that term here. So I'll say 3, open brackets, x plus 3, close brackets. Okay, so I'm done. So now we have one fraction. So now once we have one fraction, let's simplify now to make it simple. So we will clear out the brackets. So it means 2 times x, 2 times x, it will give us 2x, then plus 2 times 1, 2. Then this side will say positive 3 times x, it will be positive 3x. Then positive 3 times positive 3, positive 9. Then we'll say over 6. Then we'll say, okay, over 6, right? Then we'll collect like terms, because that's why they said simplify where possible. So collect 2x is similar to 3x, so plus 3x. Then these 2 together with 9, so say plus 2 plus 9. Then say over 6. You see? Then you continue. You say, okay. You say 2x plus 3x, it will give us 5x. Then plus 2 plus 9, it will give us 11. Then over what? Over 6. So this will be our final answer. So we have made it single and again simple. Okay, so that is it. Let's go to the next example. So another example is this one where we want to make this one as a single fraction. Again, what you do, you look for what is common for x minus 2 and x minus 3. If you can't seem to see or find what is common, just write the same ones as as being common. So what we are going to do, we will write the same. We'll say x minus 2, open brackets, x minus 3. They are the common one because we can't see a single term in which these can go. So when you do that, you say x minus 2 into x minus 2, it will cancel. Then you remain with x times 3. X minus 3 times that 3 there. So write, okay, that 3 there times this one here, x minus what? Minus 3. Then you close bracket, then you bring this minus here. Then you say x minus 3 into x minus 3. It will go, you remain with x minus 2. So this x minus 2 times that 2 there. So you write that 2 there, open brackets, this x minus 2. You have seen. So once you do that, you say equals, you clear out the brackets. You say 3 times x, 3x, minus 3 times 3, 9. Then here you say negative 2 times x, negative 2x. Then negative 2 times negative 2, positive 4. Then over. Then you have x minus 2 in brackets, then x minus 3. Then you say, okay, this implies that you collect like terms. 3, let me write properly. You say 3x minus 2x. Then you say 9 plus 4 over x minus 2. Then x minus 3. Then you say 3x minus 2x, you remain with x. Then in negative 9 plus 4, you get negative 5. Okay, then you remain with over. You have x minus 2, then x minus 3. That will be our final answer. So we have simplified and made it as a single fraction. Then we have another one here. This one has got now 3 terms. So we'll do them separately. So this one we'll say equals. So we need to simplify first. Okay? So this one is quite complex in my opinion, but despite it being complex, we can try to find the common denominator. Okay? We will find the common denominator. So let us first simplify each one of them. Let's simplify the denominators alone. So this one was giving us like x squared plus 3x plus 2. I said the sum was 3 and product was 2. So here we got 1 and 2. So to simplify this one, it will be like x plus 2x plus 2, which gave us x over x plus 1, then plus 2, then x plus 1, which gave us like x plus 1, then x plus 2. So meaning this one will say 1 over x plus 1, then x plus 2 will close, then plus, then this one is a difference of 2 squares. So I will remove this one and then use the space to solve this one down here, which is x to the power 2 minus 4 is the same as x to the power 2 minus 2 to the power 2, which will give us like x plus 2, then x minus 2. So say 2x over, then x plus 2, then x minus 2. Then plus, then I'll get this one down here. So that's why I was saying this one is quite involving in my opinion. So we'll get x squared minus x minus 2. So sum is negative 1, then product is negative 2. So we look at two numbers which when we multiply them or we add them, they'll give us negative 1. When we add them, they'll give us negative 1. When we multiply them, they'll give us 2. So these are 1 and negative 2, because 1 times negative 2 is negative 2, then 1 plus negative 2 is negative 1. So say, okay, we'll substitute now. We have known that the numbers are 1 and negative 2. So now, let me remove this part because we have now identified them. So now we'll say, okay, x squared plus x minus 2x minus 2. What is common here? X, open brackets here, will remain with 1 plus x. No. Will remain with the x plus 1. Then here what is common is negative 2. Open brackets here will remain with x plus 1. So this one will be x plus 1, then x minus 2. So here we are having 1 over now x plus 1 and x minus 2, like that. So now you have seen that's how we have simplified. Now from there we'll look at what is common. So you will notice that what is common here is when you check what is common, here we have this is common there. You are seeing, right? Then this is also common. Then this one is also common. So now you write it once. So what is common? You write it once. So say we write x plus 1, then this one x plus 2, then we also say x plus 1 is there, then x plus 2 is here, then x minus 1, x minus 2 I mean. So I've picked 1, 1, 1. These are 2 here with this one, but I just picked this one here. So I'm doing this one so that I don't confuse you. Then you see this one are common, this one and this one, but I've just picked 1 here. Okay? Then also you see that this one and this one are common, but I've just picked 1 there. So that's how it should be. So now from there now you will say this whole expression, this one entire into this one, it will cancel. You see, this one can cancel with that, that one can cancel with that, will remain with the x minus 2. X minus 2 times 1, it will be just x minus 2, like that. Then we'll come to plus. Then we'll get x plus 2 minus x, x plus 2 minus x plus 1 into this one. You'll find that it will cancel. This one can go, will remain with x plus 1. So say on top there we have 2x, open brackets, we have x plus 1. Then we'll say plus, then this one will cancel, x plus 1, x minus 2 will cancel, remain with x plus 2 times that one there, it will be just x plus 2. You have seen the way it is moving. So now what we are going to do, it is now to clear the brackets. This one will actually be x minus 2. Then this one, 2x times x, it will be like plus 2x squared. Then 2x times 1, it will be plus 2x. Then here we'll clear the brackets, it will just be plus x plus 2. Then over what is down here, which is x plus 1, then x plus 2, then x minus 2. Then I'll come this side, I'll continue from the top so that we can have clear or collect like terms like x and x. So have x plus 2x plus x. Then we'll get this one and this one. We'll have negative 2 plus 2. Then at the end we have plus 2x squared, everything over x plus 1, x plus 2, then x minus 2. So here you realize that x plus 2x plus x, it will be 4x. So 4x. Then here negative, yes, so negative 2 plus 2, it will be 0. So this one will cancel. So remain with plus 2x squared. Over down here we remain with x plus 2, plus 1, then x, x plus 2, then x minus, what's this now? X minus 2, open brackets. So what is on top there can be factorized there. So we have 2 and x which are common out. So we remain here with the 2 just, plus here we remain with x. Then over, down you have x plus 1, then x plus 2, then x minus 2. So see that this one and this one, they're the same, they will go. So you remain with, on top x, over down you have x plus 1, then x minus 2. So this one, as I said, was quite involving. So that would be the final answer. I don't think you can find a question which is like this in an exam, but such questions are good because they help you. As much as you solve, they are helping you to strengthen your brain. Then we have this one, simplify where possible. This one, it has multiplication. So we have like 2z over xy times y over 4z. So since there's multiplication, these ones you don't need to look for a common denominator. So this one, it just means this. You say, you multiply everything. You say 2 times z times y. So this one times there, then one bracket will say over. Then what is down here, you have x times y times 4 times z. So you see everything has multiplied itself. So you say, okay, 2 into 1, 2 into 4, 2. Then you see z into z will cancel. Then y into y, they'll cancel. So on top you have just remained with 1 over, down you have x times 2. So the answer is just 1 over 2. Okay, so you have seen, that's how, x actually, there's x remaining here, x times 2, 2x, like that. All right, so that will be the answer. Then we go to the next question. Okay, this is, okay, oh, we have 3 more questions. Okay, so this one, again, there's multiplication. So you say 4 over a plus b times a squared minus b squared over 12. So this one is a difference of 2 squares. So you simplify it further. You say this one, write it as it is 4 over a plus b times this one on top. Now it will be a plus b, then a minus b, because it's a difference of 2 squares, then over 12. You have seen, eh? So now this one, you can even put it in brackets. Then now this one will mean that everything on top is multiplying. So you have 4 times, if you want, you're saying 4 times, you have open brackets a plus b times, there's times, then open brackets a minus b, then down you say over, down everything you have a plus b times down here 12. So you realize that 4 into 4, 1, 4 into 12, 3. Then you realize that this one and this one, they'll cancel because there's multiplication throughout. So I'll write the answer on this side. So on top you have 1 times a minus b, you just have a minus b over, down here you just remained with 3, so 3. So that will be the answer. Then you come to this one. This one is xy over 6 divided by y over 3x. So this one there's a division. So whenever you are dividing a fraction with another fraction, this division becomes multiplication. Okay? So it will change like xy over 6. Then this division becomes multiplication. Once you do that, you swap. This one goes on top, this one comes down. So you have 3x over y. So you just swap on one side. Once you do that, then there's multiplication throughout, then you multiply. You say x times y times 3 times x over, you say, 6 times y. So see that here, you have y into y, they will go. Then 3 into 3, 1. 3 into 6, 2. So you have x times, you have x times 1 times x. You have x squared over, down you only have 2, so 2. So this will be the answer, x squared over 2. Then I think this is the last one, yeah. So this one again, where you have x to power 2 minus 4, this one is a difference of 2 square. So over 3x squared minus 6x divided by x squared plus 2x over 9x squared. So this one, first of all, let's change. This one can mean, let me do it here so that you understand. X squared minus 4 is the same as x squared minus 2 squared, which can come out as x plus 2, then x minus 2. So what is on top here, it will be x plus 2, then x minus 2 over, what is down here can be factorized if you want. What is down can be factorized here as 3 is common, 3x, then we remain with x, then we remain with minus 2 there. Then divided by this side. This side also we can factorize. We have x is common, open brackets, there will remain with x, then plus 2. Okay, then down there will remain with 9x. So now what we are going to do here, before we do anything, this one and this one are common, so they will go. So remain with x plus 2 over 3x. Then this division becomes multiplication, so it will be times. So this one goes up and this one comes down. So I have 9x over down here. In fact, here we could divide, but I didn't. So this one, yes, can go into that one, so that this 9x just remains 9. 9 goes up, then this x plus 2 comes down. So x plus 2 comes down. So again, this one becomes simple. Since we are multiplying, this one and this one can go because they are similar. Okay? Then you can say you are remaining with here 9, down you are remaining with 3x. This one can be like 3 into 3, 1, 3 into 9, 2. So, 3. So on top you have 3, down here you have x. That will be the final answer. So, on algebra, I think at least these questions can give you much understanding. So, for now, we end here. I'll send the questions in the group for you to solve. So, see you in the next lesson. Bye.